9. So chapter 8, we teach you how to create a chart, right? Maybe pie chart, maybe a bar chart, maybe plot chart. I did not complete every kind of chart, but it's okay. We can learn it later. Okay, we can learn it later. That's not really that important. Okay, and then here actually, what we want to do today is not making the chart, but starting from creation of the data and then actually making the plot and then use for package. Okay, so it's called information retrieval. Information retrieval means that before we make meaningful data representation, we need to get data from somewhere, and that somewhere is internet. Maybe from a app, maybe from a data source. Okay. So first one, we will talk about dataset. Dataset, actually, we discussed it already. You can download from data.gov, or you can download from UCI Machine Learning Repository. These are two sources of the important dataset. We actually discussed it already. So that portion, I'm not going to discuss it. Today, I'm going to talk about this Buckingham Palace. Okay, Buckingham Palace. So please do this. If you have not do this, please do pip install GeoPy. Okay, how to do it? Okay, very easy. So first one, let me follow me. Okay, follow me. Is that okay? Hear me?
Mm-hmm.
So the first thing is that please do Window R. Okay, Window R, you bring up this run menu. So let me, I'll try stay slow, okay? Stay slow so you will follow me. Window key is the control function and then window key. Window key parts R key, okay? R is wrong, okay? So here you bring up the wrong box and then type CMD, command line, CMD, okay? So that's bring up the DOS-MO. So, okay. Okay, here you jump to USR, Eric, whatever. Okay, this one actually just do CD, okay? CD to where? You go to your C drive, okay? Maybe some of you are D drive. Remember your Python installation directory, right? Go to Python 36. Okay, over here you have Python W, Python D, whatever here, okay? At this location. Is that okay? To this location, okay? Is everybody following me?
Mm-hmm.
Yeah. How about Jessica? Are you following me?
Yeah.
Yeah. How about Amber?
Yeah.
How about Ophelia?
Yeah.
How about Ryan? Are you there?
Yeah.
How about Albert?
Yeah.
Yeah. Okay. I check everybody because I want to make sure you are here. So now do this one. Just come to this box. Let me try again. Okay. Left click, mouse left click on this one. Mouse left click. Okay. Left click. Your mouse, right? Your mouse click on the left side. Okay. Try again. Left click. You got this one, right? Then right click. You see this one. Copy. Okay. And then come to this window. There's a CD space. Type CD space. Right click. You paste this one. And then hit return. You jump to the directory. If your machine is actually your directory is in D drive, please do D column. You jump to D. Okay. And now come back to C. So basically, these are the file systems. Your computer may have multiple hard drive. Okay, let's check again. Here I have this PC. When I go to the PC, actually I have C drive, D drive, E drive, F drive, G drive, H drive, and actually this H drive, F drive. The F drive today I'm going to retire it. Okay. I just bought a 10 giga drive, 10 terabyte drive, and this F drive is already 20 years old. Okay. This hard disk survive for a long time. But anyway, you come to here, you do D column, E column, F column, it jump to different hard disk, okay? And each hard disk has one file system. Each hard disk has one file system. Okay, so what is a file system? File system is that you have a root, root also called slash, under slash. Like this hard disk actually, you will see that my F drive, under my F drive here, I have a Hawaii, right? I have a sugarcane. I have a watermelon. I have a war elephant. Okay. So that's different directory. So I can actually go into there. So if I want to go into sugarcane, I go cd sugarcane. Okay, yeah, that's a directory, and then cd hold photo. Okay, something like that. Okay, if you want to go back to the top level, you do cd f colon /, you jump to the top level for F drive. Is that okay? That's a pass. That's a pass. And each hard disk, we call it a file system. And your computer can be connected to multiple hard disks. And you may also, some of you may have SSD drive, maybe 512 gigabytes of the SSD drive, maybe 256 gigabyte of the SSD drives. SSD means solid state drive. So it's down by, it's a hard disk using transistor, okay? But anyway, you actually will have this different drive. But you jump around different drive, but here I will go back to my C drive. Okay, and here is the directory I have. And this one has the python.exe. exe is an executable file. So this one is really the Python you're running. Whatever file with the exe will be runnable, okay? In those systems, the executable file usually has 3 extensions. One is .com, one is .bat, one is this one .exe, okay? And .com now is already gone. Nobody actually continue to use .com. It's an old day, there's a .com, but .com right now no longer supported. .com has a limit of actually what? 256 megabyte memory maximum for the image. Okay, one sector. So .com is an efficient program, but actually recent 10, 20 years no longer there. Nobody supported anymore. So no more .com. It's only .bat and .exe, okay? .bat is a batch file. .bat is executable batch file. And you must know this, okay? When you go to college, you will have to deal with Linux. So .bat is actually batch file. Batch file means you process many things together. Okay, and exe is a real executable file. Okay, anyway, that you are here. Once you are here, you go back to see this one, the installation guide. Where is in the installation guide? Let me see. Oh no, on my slides. So pip install GeoPy. I mean, that's all I want to say. So basically, you get the Windows CD to this directory, and you just do pip install geometry GeoPy. That's it. Okay, hit return and go. I have already installed it, so I don't do it. Is that okay? Now let me actually leave this here. Pip install GeoPy. Is that okay? And hit return. You will install a GeoPy for you. Any question?
What if you're not sure if you downloaded it before and you do the pip install GeoPy? Is it going to do anything?
It's okay. I think they will actually check it and he say it existed already. So not a problem. just pip install and GeoPy. Is that okay?
Mm-hmm.
Any question?
No.
Okay, just run it, okay? Is that running okay, everybody? Who has the problem? Who has problem? I can actually try to help you, okay? Amber, are you okay?
Yeah.
Yeah? How about Jessica, are you okay? Hello, hi Jessica, are you okay?
Yeah.
Yeah? How about Ophelia, are you okay?
Kind of.
Kind of.
Yeah.
Is that installing? Have you got your machine?
No.
No? Okay, we got a machine. Let me actually install everything for you. How about Elba, are you okay?
I don't think so.
You don't think so? Okay, I'll check. Ryan, are you okay?
Yes.
Okay, you're done. Let me actually check Elba. Okay, Elba, can you show your screen? Let me see what happened to your GeoPy. You go to where? You got MinGW. Okay, you actually try C language. Where are you right now? Where is your Python? Let me see. Can I control your machine? So you don't know where is your Python. Let's go to this PC, okay? So this PC, you only have C drive. You have C drive over here. Oh, I remember your Python actually not installed by me, right? You have your own way of installing. You know, that's the problem. I mean, okay. Anyway, we can take a risk, okay? We can take risk. So just type here pip install GeoPy. Yeah, it may work, but I don't know. Your pip is not, so you have to find your path is not your path is not actually done well. You know, the problem, you know, that's what I told you. You have better follow my instruction to do installation. Because whenever you go into your installation, you will see this over again, several 200 times whenever you try to install something. So here you have a Python. This one is a project array. So it should be in your maybe PC users. Where is the users? So you should be this drive, C drive, you have users. So don't go to your users, and then this Elber, app data, yes, this one, local. I actually don't know where's your Python. You know where is your Python? Hello? Hello? Hi, Elber, you know where is your Python?
I think I think it's over here somewhere.
Roaming. Yeah, the word roaming. Roaming is under roaming. Here, roaming, this one, roaming. Go. Can you click that one? Click roaming, Intel.
Oh, well, maybe I can do,
Yeah, you actually find your app data or something. Okay. Anyway, I think Albert, probably I need to help you some other time, okay?
yeah.
This probably will drag us for too long. Okay, sorry for that. Yeah, I told you. I mean, the installation is very tricky for Python. Must follow my instruction. Otherwise, it would take a long time to, and you will not be able to get out. Okay. So anyway, this GeoPy is a package, and then here we actually, if you want to see the document, GeoPy, only GeoPy itself, you will be able to do a lot of things. So here you come to here. Let me actually copy this one. This one is installation directory. Okay. But let me actually put it here. Okay. So you can have a reference of where the install page is. Now the important thing is that you probably would like to do home page. Home page. Okay. This one is not a home page. So what I want to have is, let me see, geocoding, okay, geocoding, measuring distance, programming language, documentation, read the doc, okay. What I want to have is GeoPy documentation. So this one, let me copy again. It's actually the documentation page. This is more important, okay. So we say that we actually want to do things here, information retrieval, because we want to actually get the data from here, okay? So actually this one, you have the documentation, you have source code, you have whatever, many things you can look at, okay? So contents, here it has Baidu, ArcGIS, actually also MapQuest, also different things. So let's click this MapQuest. Okay, MapQuest will tell you how can your Python program connect with a MapQuest API. So what this really means is you get the API key, you bring up your browser window, you should be able to have your Python program to talk to it, put data to here, get data back to here. Is that okay?
Mm-hmm.
So that's what today we are not going to try this one, but I just show you that this is possible. But some other day I may show you how to get the data from MapQuest and get the data come back to here, and also Google Map. Okay, that's the purpose of having the GeoPy. Is okay? So today we are not doing that because that takes longer time, and it also is actually more difficult. But here, as you can see, it has whole bunch of geo-related issue, and geography actually is an important topic in data science. Okay, so research internship for high school student, and here it actually has a program on this geography program. Okay, I actually don't see. I mean, not this one. There's a no, that's a genome. That's different. There's a this one's genome. No, I'm getting the wrong one. Earth Young Investigator. This one. It's an internship. Okay, geology, energy, whatever. Okay, anyway, so they are something you can search. They are studying something like this, okay? And you can find some internship over here. You have to contact the school early, okay? If you, okay, the problem with this is that you have to be very interested in a related area, okay? And I do not suggest my son to go. He is more double E guy, so, but if you are really interested in geometric information system, GIS, you should go there. Okay, it's a good opportunity. And it's very important for doing programming such as Uber or something will need that. Okay, so here today we start to use this package, and And we are using a very basic, simple one. So the first thing is you go to here, get a document. So next one is I'm going to get the from GeoPy import distance. Distance is a function, okay? And my home Tyson home would be this one address. So let's try this one. Okay, let's try something here. Create a new program. So actually, let's try a new program. So new project. Okay. Okay, this new project in CSP 20. Okay, this one chapter 8. No, I'm going to actually over here PyCharm. So over here, I'm going to create a new directory. This one called, so you can try your own, okay? If you want to try as well, you can create a new project for yourself. So here, I just create a folder. I did not create a project, okay? Here, over here, I have chapter 9, okay? And then make sure that you are using existing interpreter. Don't use a new one. And then create, okay? Open new window, yes, open new window, okay? So here, let's try this one and try new Python file, okay? So I'm going to try Washington. Okay, Washington. So Washington, the Python from GeoPy. Okay, that's actually not using this one. I'm trying to teach you actually only import partly. Okay, so here let's try GeoPy as GP. Okay, GeoPy. So from that we import this one, and we are going to do Washington. Let's do shorter form, WHS. Okay, equal a tuple. Okay, equal a tuple. What tuple? So here let's actually get the data. Okay, so here come to here and do Washington High School, Fremont, and then get the map. Okay, get map. Okay, I told you the data is hidden right here. 37. This is things. Copy this guy. Okay, copy this guy and put it over here. Okay, so that actually is my longitude and latitude. Okay, and which one is longitude? Which one is latitude? Here we have a Earth, right? Let's assume that here we have Greenwich over here, right? So this is 0 degree, right? And here we have minus 120. Is that longitude or latitude? Latitude, right? The other one is longitude. I don't know. I may spell wrong. Which one is this vertical line? Which one is this one? Yeah.
Longitude.
Yeah. Okay. Longitude. Okay. So here there is no A. I'm sorry. So yeah. So here, this kind of app is also written by some sort of thing. So let's try this one. Actually, this one, let's try minus 120. Okay, and 37. Let's see where it is. If it's close to Washington Hospital, then actually it should be okay. It is. No. Okay, so here actually it's Washington High School. I'm sorry. We can't find. Okay. Let me use my pages. We still can use it. So let's try. So this one is very coarse. I'm sorry. This one is poor, very poor. think it only take California and then maybe USA. I think it, what is that? Let's try San Francisco. Still can't find it. And this is almost for better. Okay, zip code. Yeah. And this zip code is totally wrong. I mean, where it is. No. So I think longitude is actually, well, longitude is X. So this is longitude. Is that okay? And latitude is actually the angle to your Earth's center. Is that okay? The theta here. Is that okay?
Mm-hmm.
Is that okay? So longitude is actually the angle here. Okay, let's actually look at the ball. Earth's ball again. Let's try look at Earth's ball again. So if I have an Earth, right, and you have a line, this is your 0 degree. So here is make a circle, right? So basically the so-called longitude, I think it actually this 0 degree minus 120 is over here. So actually it's from here to here. This angle phi is this one, okay? And your latitude actually is from here to here to here. Okay, so here to here, you actually is from the center of Earth. There's a theta. So this theta is showing here. Is that okay? So your location is by this theta and phi. Phi is longitude, theta is latitude. Is that okay?
Mm-hmm.
That's the longitude and latitude. Is that okay so far? Amber, is that okay? When you read the longitude and longitude actually is X dimension. Latitude is like Y dimension. Actually is like the angle above the equator. Is that okay? The angle above equator is called latitude. Okay, so latitude, longitude, it must. I never get understand which one is which. Okay, but whenever I check internet. Okay, Ryan, is that okay?
Yes.
So we got this one. We actually had a geopi. Okay, so the next thing what we will do is actually not this one. I'm going to actually let me see. This one. Not this one. Okay, I should put it on my here. So that's my home. And the next one, I actually want to do NumPy. So I need to import NumPy, no problem. Degree to rad. Okay, degree to radian. And that two tuple, so I put it there. Okay. So 0 is the latitude, 1 is actually the longitude, no problem. So here, let me try this one. So I also need to use import NumPy, okay, NumPy, so import NumPy as NP, okay. So here I'm going to actually do actually W is a Washington High School, so W lat equals NumPy dot actually what actually degree to rad, okay. So NumPy has this function degree to radian, okay. And this one, I'm going to put Washington High School's first tuple to it, okay? That will create Washington High School's latitude. And longitude will be equals this one, degree 2 rad, and then WHS 1, okay? So here you can also say WHS, what? WHS radian equals this comma this. Is that okay?
Mm-hmm.
Any question so far?
No.
So for degree to radian, remember that I told you probably before, you have 45 degree, right? The whole circle is 360 degree, and this one we do theta. Theta actually is a measurement of union circle. The length of this one will be your theta. So here 45 degree would be actually pi divided by 4, okay? Because you have a whole pi here, 1, 2, 3, 4, okay, pi divided by 4. So you get that one, and you get this one. Okay, these two are good. So I get that one, actually I get this, and I'm going to calculate the xt, yt, and gt. Okay, what's that? Here, actually, let me draw the burst ball again. So this time, let me try this one, okay? So here, 0 degrees still be here, okay? And this one is actually Earth, and then what we don't see is over here, okay? Next one, our target line is over here, okay? So here, this one from here to here, this one actually is my longitude, okay? And latitude is over here. So latitude, center of the Earth over here, okay? And then you have actually this one actually is theta. This one, I'm sorry, this one is phi. I call it phi, right? This one actually is theta, okay? So here, okay? So that's assume that actually this point is 0, 0, 0, okay? This point is 0, 0, 0. And this is actually, let's cut the circle out, okay? Cut the circle out. So here actually, if it's 0 degree, I'm at the 101 degree minus 101 degree over here, right? Is that okay?
Mm-hmm.
And then there's a G, that's a worry about G later. Is that okay? Let's worry about G later. So here actually, I have this one, and the length of this one, the length of this one is what? Is the radius of Earth, right? So we have the radius of Earth. So here, this is radius of Earth. So basically, this one should be what? Should be what? R cosine theta, right? And actually, this is R cosine theta. So this portion here, this is R sine theta. Is that okay?
Mm-hmm.
Yeah. So that actually we can define the x and y over here. So let's actually go back to bring my slides back, okay? So bring my slides back. So let me clean it. Okay, clean it. So basically, my xt is my cosine theta times np sine theta, latitude. Okay. Okay, good. Let's actually try to use this equation here. Okay, let's try again. So let's assume that actually here is my line, right? Here's my line, and here is actually my circle, okay? So my location is over here, right? I'm trying to calculate, here is 0 degree, here's 0 degree, here's minus 121 degree, okay? So here actually, I'm trying to find the projection of this guy on this one, right? Right?
Mm-hmm.
My real edge is using this one, not using this one, not using this one, not using the green one, right? So H is using this one, right? And this location on the surface actually is theta and phi, right? That is my longitude and latitude. So this angle actually is theta, right? Theta is my latitude, okay? So I need to find the projection from my here to here, right? So this one actually is the length of the Earth. It's called R. So this length over here is called R cosine theta. Is that okay?
Mm-hmm.
So let's bring the equator circle now. So on the equator circle, I have this one, right? And here actually I have a phi over here, right? And then actually my point, actually my projection from my Washington hospital on the equator plane, on the equator plane, I should have a projection over here. And this length is called R cosine theta. Is that okay? Then based on this one, actually I do this portion is called what? This portion is called r cosine theta times actually cosine phi. This portion is r cosine theta times sine phi. And this one will be my x. I'm sorry, this one will be my y. This one will be my x. And my g actually is this one. My g is over here. My g is over here. So my g actually is r sine theta. Theta is latitude, phi is longitude. That's why I don't want to touch the getting the coordination from math yet. I want you to do math first. Is that okay? So this theta h is latitude, phi is longitude. Okay. So this height, how high it is, what happened though in terms of this is like Earth's center line, right? Axis, z-axis, Earth's z-axis. So you need to do your projection from here to here, and this one is r. This is theta. So this length is r theta, r sin theta. R sin theta is your z direction coordinate. Is that okay? As for x coordinate and y coordinate, you need to calculate your vector for the Washington Hospital to the Earth's equator plane, and that actually this projection is r sin cosine theta. Then r cosine theta actually time cosine theta and sin theta, you will get the x and y. Is that okay?
For spherical coordinates, phi is actually the latitude and theta is the longitude.
I'm wrong?
Yeah.
No,
Like
okay.
that's how I learned it.
That's how you learn it?
Yeah, because like phi starts from the like positive z and then goes to the negative. It has like 180 degrees, right? And then theta has 3.
This one this one is what, longitude or latitude?
Is that latitude?
The second one is longitude. Whatever, minus 120 cannot, okay. Minus 120, actually you have a ball, right? This angle cannot be over 90 degree or minus 90. Yeah, that's for sure, right? It can only be from 90 degree to 0 degree, right? To minus 90 degree, right? Yeah. So this second one is what? Tell me second one is what?
Yeah, but in math you still call it the first one is called phi and then the second one is called theta. Because in a spherical coordinate it's like rho phi theta, I think.
You mean the theta and phi are wrong?
Yeah, they're just switched, I think.
Okay, whatever. Okay. for me, I don't care as long as the number is correct. Is that okay? But how about the first number is latitude? Is that okay? Right or wrong?
Yeah, you can't have like negative 121 for
first one.
Like, huh?
First one minus 121. Now this data I get it from where? From the Google Map, right? So it can't be wrong. But the name can be wrong if I actually use the wrong. I care about this latitude or longitude name. It's wrong, is wrong.
Huh?
Latitude and longitude. If the latitude and longitude are correct, theta and phi is okay. I can name it any name. You know what I'm saying?
Yeah.
Yeah. Anyway, so if the list is latitude, that is any longitude, then that's fine. Okay. Okay. That's actually well, I have to check, but let's do this way. Is that okay? So we have this one, we got this one, and that we want to calculate the XYZ. So here we have XW, YW, and the ZW. Okay, and XW, YW, we talk about it. This one is actually the radius. Okay, we need to find the radius. So actually the radius, let me try to find. Okay, if we are using the number of kilometer, okay, kilometer. So here we have this one. I think is on the unit circle. Okay, it not even actually had the radius, but let's do have a radius. Okay, that's a unit circle. So here let's do Earth. Let's do R. Okay, radius. Okay, let's do radius. So radius number. Let's try to find. Okay, let's try to find Earth's radius. So let's just use this number, okay? Because we are not trying to do everything correct, okay? Just because there are several ways to measure it. There's a longer one, there's a shorter one. So let's pick this equator one, okay? This equator one. Yeah, people may use a theta or phi, whatever. That a lot of different systems. So let me check one more time the latitude and the longitude. Okay, whatever. I must get it right. Okay, go to this one, stupid one. Wikipedia. Okay. Yeah. So latitude is the angle from your line on equator to the line of your angle. Is okay? So these two are correct. But theta phi, I know maybe it's wrong, but it's okay. We don't. That's only to show the mass. Okay. So this one actually we have this one. So my radius actually times what? Time my numpy dot cosines, and here should be W latitude. Okay. Times cosine numpy dot cosines. What? Longitude. Okay. Okay, the purpose of this one is actually help you to do some calculation, okay? And okay, here, and we do the last one, radius times numpy the sine of W long. Is that okay? Mm-hmm. So you can keep the angle and time radius later, okay? But here I actually have XYZ. So here let's do VW, vector of the W, okay? And you can actually do what? Do arrays that numpy that arrays. Okay, then you will be into where you will become a vector system. Is that okay? Mm-hmm. You will bring it into vector system. So numpy has the advantage of doing that. Okay, anyway, we finish with this one. And we want to print the three numbers. So we want to print the three numbers. So that actually is my home. No, that actually is. So that is okay. So this one is my home. I don't use my home. So we would try to calculate the distance for the two. Okay, later. Okay, later. So here we have this one. There is a vector. Okay. And then let's try another point. Okay. Try another point. The other point, let's try very close location. This is Washington Hospital, right? Let's try another location. The other location is called, this one is Washington High School. So let's try another location. The other location is Washington Hospital, okay? So very close. So we will see how long they are, okay? Washington Hospital and Washington High School, probably half a mile away. but that's actually also get the data. I regret, no, that's not doing this one, too short. E to make errors. So let's try James Logan High School, okay? A little bit of distance there. So we have this one, so catch this number over here. Okay, this is James Logan number. Is that right? Is that Union City? Yeah, that's Union City one. So get that one, we actually put over here. So this one is, let's call it James, okay? Let's call it JM shorter. So we got this one, and then the same thing, we actually copy the whole thing. Okay, copy the whole thing, and we put it here. Okay, so here let me change it to J. And here I should put JM. Yeah, every profession has some. Every profession may have some custom. Okay, so someone like me, I'm not a GIS expert. So sometimes if I use the wrong CDA, people will know that actually this guy is not professional. You know what I'm saying? So it's easy to spot someone like that. Okay. Okay, these two sprays, we actually have two vectors. Now we have two vectors here. We got two vectors, right? So two vector, how can we have two vectors? How can we figure out the distance from this point to this point? Vector 1 minus vector 2. Vector 1 minus vector 2 in NumPy would be A, B, C minus D, E, F, right? So you will get A minus D, B minus E, C minus F, right? And then we do square. We do square. And then we do sum. And we do square root, right? So this one actually I don't need to time itself. Actually I can do over here to numpy the square. Is that okay?
Mm-hmm.
Numpy the square, that would be this guy, each element's square, taking sum for every one of them, and then taking square root for that scalar data. Okay, so let's do print. .8 miles, maybe. Four mile. Yeah. Let me. 4 kilometer. So 4 kilometer. Okay, this is actually 4 kilometers. So here is percentage F. Okay. So let's do 6.2 F. Okay. Kilometer symbol. Kilometer symbol. 339E. Okay. 339E. So backslash U 339E. Okay. And then here I should actually do percentage distance. Yeah. So here let me give it a space. Okay. So here I also need to have another one called mile per kilometer. Okay, mile per kilometer. Let's convert it to mile as well. Mile, remember, is about 2.8. Okay, so mile per meter. This one per kilometer. Okay, so actually this number. No, kilometer. Kilometer. That's correct. So let's put it here per kilometer. Okay. So this one actually copy. This one actually distance time mile per kilometer. Okay. And the unit change to mile. Per mile sign. Per mile sign is 2030. Okay. Okay, let's run this one. No 2030. Working point. Distance times mile per kilometer. Distance time mile per kilometer. So this one I think it will require me to actually put this guy on, okay? Yeah, actually, what? That's what's that? This one's mile symbol. Is that mile symbol? That's called per mile simple, but not mile simple. Okay. It's a Unicode mile simple. That's called per mile, every mile. So mile per gallon per mile. So I give up, okay? Here I just say miles. Okay? So this one show you actually getting the GeoPy. No, we are not using GeoPy yet. Here, this one is the math. If we do calculation all by ourselves, okay, all by ourselves, this is the way to calculate it, okay? But I do use the NumPy for calculation, okay? I do use the NumPy for calculation. So this one actually give you about 2.63 miles. Okay, I know it because at that time my elder son tried to take AP computer science. I need to rush from Washington High School to James Logan. So I actually checked the mileage between Washington and Mission, San Jose, and Washington and James Logan. They are about the same distance. So I checked that. That's about that 2.6, 2.8 range. Okay, so anyway, we finished this portion. Now is the what? GeoPy will come to help, okay? Is that okay?
Mm-hmm.
So GeoPy will come to help. We have these two numbers, and we are going to use GeoPy directly, okay? So this whatever calculation we have longitude, latitude, and Tyson Home and the what? Tyson Home and Buckingham Palace are two set of the latitude, longitude, okay? So let's try copy these two over. Let's try copy these 4 over. Okay, so distance, let's do this one. Don't call it just as long, and let's do dm. Okay, and there's a distance here. You don't have a distance, so here this one I need to do GeoPy the distance. Distance is a package. Okay, let me see. I asked for trouble, so no, I'm sorry. I changed my mind. Let's steal from GeoPy import star. Okay, I'm sorry, import distance. So here I will still be using distance. And here this one, let's try. This one would be what? Washington High School. And this one should be James. Okay. And this one change line. This one distance by kilometer. And how comes I don't have this distance? From GeoPy import. No, let me check, okay? Let me check something wrong. From GeoPy import distance. Yeah, that's correct. Distance. So actually, I already put in the GeoPy the distance. Do I need the GeoPy? What's this? Okay, anyway. Let me delete it, okay? It may be right already, so nothing to worry about. So let me actually put this over here. So this one must be changed to DN. This one must be changed to DK, okay? This one let me change to WHS. This one let me change to actually James. Okay, there is no ES, let me delete it. This one is WHS. So to set WHS and also James, and then the mile, the kilo, distance, the distance. Okay, this one correct. So here distance of WHS, and this one change to gens. Here may be some hidden data as well. Some hidden data as well. Okay. So I think there's some hidden data there actually cause the trouble. Anyway, here actually let me save all and run. NumPy has no distance. Which one's wrong? So it's not actually distance. Distance. That's actually do from GeoPy. Let's do this one, okay? Import GeoPy.distance as GD, okay? Import GeoPy.distance as GD. So here no longer use this one. Let me call it GD. I think maybe NumPy has a distance package as well. Okay. So here I change my name to GeoPy.distance as GD. So this package is distance module used as GD. Oh, the number actually has some discrepancy. Is that okay? The number has some discrepancy. Who actually is correct? Who actually is correct? Of course, his number is correct. My number is wrong. A few factors here. Number one, I'm using this this method to calculate it. Okay. And number two, actually, the real distance is like this. It's not this arc. That's another order of issue. Okay. So also this one, the way I do this calculation for this distance, this one may be wrong. Let me try to improve this one. Okay. Let me actually improve this. Oh, here I actually already used the word distance. So maybe that's why it actually creates trouble. Here I already used the word distance. So let me try a different way to do it. Let me bring up my original way of calculating it over here. So here I have this one. So actually I had NumPy array using this tool, and then there's a zero array, and do inner product. And I use the inner product to calculate the, it's actually quite complicated. Got the norm of the V and W. So actually I use the inner product for it, okay? So basically what I'm using actually is I have a vector V and I have a vector W. So I know this inner product for this one, V inner product with W, it should be the length of this guy times this guy times cosine theta, right? So I'm trying to calculate the distance actually from here to here, right? And this angle actually should be very small. This angle should be very small. So it's almost like the R times sine theta over here. Almost like IR times sine theta over here. Or R theta. You can actually use R theta to approximate it. Okay, you can use R theta to approximate it. So we actually try to figure out the cosine, the theta, and then actually use R theta. Then I will be able to find. Is that okay? That's the method I'm using here. And what's wrong with the one I'm using over here, the other here? This one actually I do the minus and square, so I calculate the square sum. I actually take the mean square sum. This one should be okay, but this one actually, I don't know why, but this one actually not really that close. So that's actually call this one D1, okay? Call this one D1. So using D1, we get this result, okay? And let's try the other way called to get D2, okay? This way we can get D2. So this V and W using NumPy, we got it already. So there's a 0 vector here for 0. So the norm minus 0, we have this one. We try to get the, so the norm actually is this one, okay? So let's do this one, okay? Let's actually copy from here to here. We got the theta, up to the theta, okay? Up to the theta. It's not really hard, so let's actually get this one. Put it over here, okay? And let me actually bend it down, okay? This printing part, I think I can delete it, okay? Printing part is not important, so let me actually take out the printing part. Let me check my note, okay? So here actually both are 1. So both are 1 over here. This one should be okay, not much actually over here, okay? So here we have NumPy. Let me delete the wrong symbol at the end. Okay, over here we have the last vector. We actually have the vector Vj and the Vw. Okay, so we have the Vj and Vw. So here this one we actually NumPy inner product of Vj and Vw. Okay. So here let's say this guy called Jw. So here we have J absolute value is Vj minus 0. This one is Vw minus 0 plus W absolute. This one is J absolute. And then we have here Jw. And then we have J absolute times W absolute. And then here we do have actually J absolute times that one. Here we have JW. So eventually we got some sort of theta, okay? Some sort of theta. And this is a printing command that's actually remove it, okay? Once we got a theta, we can do D2 equals actually radius times theta. Second way to calculate it using another way to calculate. The first one is mean square error take square root to calculate the distance. Okay, I don't know why, but that seemed to have trouble. So here, let's actually do this one, copy these two lines again. Okay, put it over here. Okay, and here let's do D2. Okay, now that's wrong again. This way is even worse. So I mean, well, here I don't know whether I made mistake in the middle of the calculation or not. But basically, well, VW and VJ. I don't know whether I made mistake on the second calculation or not, but here I list down different way of calculating it, and the number may be wrong and or maybe not close because there may be some systematical error I have introduced. Okay, but it's up to you to continue to verify. I actually will verify later. Okay, this few things let me actually delete them. Okay. This here, the distance is 7,000 something, okay? It's not actually, it's actually way too long, way more than 3,000. So the V actually is, V value is too long actually. So we actually, Vj minus 0, taking the norm, actually the number is quite big, okay? I don't know why, but actually it's quite big. So let me check here. Go back to here, cosine, 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 sine, sine, cosine, 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 sine. Anyway, I have to check, okay? Any question here so far? So you see that actually I use a 3 system to calculate actually quite different. And now say who is right. Of course, my calculation may be stupid, okay? Of course, his is correct, right? They verified it many, many times. I haven't verified my method yet. Is that okay? I think my main mistake is what? My main mistake is I pick a wrong location. James Logan is too close to Washington. So the angle is really tiny. This angle is really tiny. I ask for trouble. You know what I'm saying? That is really tiny. If you use a Buckingham Palace and my home, that is quite a long distance. So it's more like a triangle. Here, this one actually is probably like this. You know what I'm saying? Really short. This is 6,000 kilos, 6,800 whatever, 6,300 kilos. Here is just 3 or 4. Actually, is, I mean, well, it is easy to create numerical trouble, okay? So here I'm not trying to actually, I think to verify it, it actually may not be a good idea because of the 2 distance I pick is actually not easy to actually to find a good solution. So a more interesting way to do it maybe is use this guy to calculate the distance. Washington High School, 4.3 miles, right? See? By driving, it's a 4.3 miles. And the red distance, I think, is shorter. Is that okay? Is that okay?
Mm-hmm.
So here we have why this one? Actually, this is actually what? What is that? I think the measurement probably, I don't know. It said a 4.3 miles. Is that the red distance? I don't know. Okay, anyway, this actually is probably easy to get an error, okay? Anyway, so that's that. Actually, we got the 2 distance, but got the distance by using GeoPy's distance function, okay? Then next one actually, well, let's bring back this one. Probably the Buckingham Palace make more sense. Buckingham Palace. So let me actually open the project. That one is chapter 9. Okay. Buckingham Palace. Okay, let's open this project. Okay. So here I'm in first one. Let me try this one. Okay. So here I calculate my home address and use this to calculate X and Y. Okay. And Z, and also calculate the other location, Buckingham Palace, S, Y, and D. And then I use the inner product to calculate the theta and calculate the distance. I also use the GeoPy for it, okay? And then up to here, we are up to here now. So let's run to see this data. So far up to there. This one's called Buckingham Palace. Okay, so here actually we got, here up to here we actually got somewhere the calculation, actually hand calculation and the real data is quite close. The discrepancy about, I would say 20 to 23 kilometers. Okay, so that's way closer compared to the one I have. Okay, so that's actually that. And then after that, we are going to draw this ball like this, okay? So let's look at how we can draw that ball. So here, this one's Buckingham Palace. So let's try to go back to our slides. Okay, the first one, I would like to draw a chart like this with a rectangle frame. Is that okay? So to do that, actually, that's called draw cube. Draw cube, I need to, from the MPL toolkit that MapPlus3D, and then import the axis 3D, okay, and MapPlus I need to have the MapPlus and NumPy and the MP and iterate tool to get the product and combination. Okay, these are the package I need to have. Okay, and I can draw different things based on these. Okay, let's do one by one. So the first one, if I want to draw the cube, okay, so basically I create a figure. This figure is actually using MapPlus PyPlus that figure. Okay, so usually if we from Pilot import everything, you don't need to have this one. And I told you must run this one because sometimes we need to save for one figure because we may have other figure we want to have. Okay, so here actually I do create this figure, and the figure name is called Earth. Okay, a figure size 12.9. That's the inches. And then I say get current axis projection 3D. That will become a projection 3D axis, and then set aspect equals. Okay. And here I want to draw cube. Okay, so basically this part draw cube. So from S and E in the combination NumPy list, product R is actually 0, 1, 0, 1. So basically this product will create 8 different points. Here, 8 different points. And the 8 different points will be put into a NumPy array. And the NumPy array, it will actually list down the A combination, and each one will give you a S and E. The S and E is actually the X and Y, but it's in 3D plot. In 3D plot means it actually absolute value SY. Well, the plot is 3D, but actually the number SE are in 2D. So you get that 2D number and will be printed over there. Okay, and then axis plus 3D, right, and color black. So the axis actually being colored as a black color. Okay, axis color is black color, and then we will draw cube. So now let's look at the draw cube, okay? So up to here, we will draw a cube. So the draw cube give you the idea of draw cube, okay? If you remove the blue one, the cube portion, that's actually remove this cube portion. If up to here we remove this draw cube portion, it will give you, so this portion, it will give you the 3D basic space. Is that okay? Is that okay?
Mm-hmm.
So if you want to draw a 3D space, you pretty much import this. When it become gray, means not used. So you just need to actually import this matplotlib pipeline, and then create a figure and then projection to be 3D and set axis. That's it. That's all you need. Okay. That's all you need. You don't need to create this cube. Okay. Then you don't need to have this. You don't want to plot in 3D projection, spatial 3D plotting the point. If you don't do spatial 3D plotting the point, your projection is 2D. That actually is fine. You will actually get this 3D coordinate. You will get this one. Okay. So here, this portion is just to plot the cube. Plot the cube. Okay. This portion just to plot the cube. So here we create that cube, and this one is because that if we want to draw a 3D vector, it's actually better with this. Okay. It's better to have this one. So that's the first part. Second part, I'm going to draw a ball. So I still create a 3D figure, right? Earth. And then this time I'm going to create U and V to draw sphere. Sphere is a ball. So this U and V is what? Jessica, U and V is what?
Vectors.
U and V somewhat like our latitude and longitude, right?
Yeah.
Yeah. So here actually, this is U and V pair, not exactly the same, but let's analyze it. Okay, let's analyze it. So basically here I have a vector, right? And I have U and V, two number. I think U and V are two angles as well. Okay. There are two angles as well. So here actually, let's see, is 0 to 2 pi. This one 0 to pi. So apparently this U actually is a vector, is a number actually goes through like this. And actually this V is, I think it's actually some angle like this. Is that okay? Because it's only have pi. So this one actually maybe is what you say, the one actually just traverse for actually half circle. You know what I'm saying?
Mm-hmm.
And I believe actually maybe let's see. Okay, maybe that's that. So here actually your x is the sine. So apparently xy right now is actually it's a sine value, right? xy actually is a sine value. So basically, if xy is a sine value, then I would say if this is a plane, this is actually x, this is 1, right? X is 1. I think this theta is this one. So it's actually V, right? This is V. So V actually is this one. Is that okay? So I think V is sweeping from here to here. V actually is calculating from here to here. You know what I'm saying? This is the V system we have. But it's from 0 to pi. Is that okay? That's my point?
Mm-hmm.
Okay? It's similar to what we are using, but it's something like this. And then G is cosine. G is cosine. I think it actually G is actually doing the projection from here to here. So you get this right here. This is actually the the V angle. So I think this one, U angle, I think U angle is, you get a projection here and then you try to check the U angle here. Is that okay? Okay, 3D usually when you convert to 2D, 3D sphere convert to 2D, you can use this MG grid to do it, okay? So if you have unit vector over here, you do some rotation, you should be able to use this one to show it. Is that okay? You can use that to show anything on top of the sphere. And sphere, if the length is 1, it will be uniball, just like your unit circle on 2D circle, right? All right, are you okay?
I don't know this math. Yeah.
Yeah, I know, it's too hard. How about Amber, are you okay? Probably also very tough for you, right?
Yeah.
Yeah, so just listen, okay? Here actually, probably too much for you guys, but it's okay. So with this one, we actually, so these two actually, let me repeat again. These two actually, we have U and V, right? We have U and V, so this a circle. Here we have the initial circle here, we have U angle. So U actually can be different angle like this, right? And we have another one called V angle. V angle starting from here, the axis of the ball, and this from here start to have a V angle. V angle will grow from here to here. So it's 0 to pi. Is that okay? I think the last third one is a step size. I think it's a step size. Is that okay? Third one is step size, so maybe 20 degrees or something. So 0 to 2 pi, make a circle, so it's starting from here to make 0 to 2 pi. The other one actually 0 to pi. And we calculated out, we got SYG data. And the SID data, we use a plot wireframe. Wireframe means that we will create wireframe, and then do scatter chart. Scatter chart, this one is just drawing the original point, green original point. Wireframe, actually, to create a wireframe, you will see that. Okay, that's wrong. So that's a wireframe. You create a wireframe and you create the green dot. The green dot is actually this green dot, size 100. The ball is quite big. The original point ball is quite big. You can do this scatter chart. And your UV, from your UV system, you calculate your SYG. SYG is a 3D vector, and use that 3D vector, all the 3D vector you create a 3D wire frame, okay? So that one will give you a ball like this, okay? So this ball or whatever it actually is a reference grease, okay? So now we finish the ball, and the next one is that we want to draw a vector, a simple vector from point 1 to point 2, okay? So we want to draw a vector. So next one, draw a vector. Draw a vector, actually you still create a 3D projection chart. Then you need to, it's more difficult. You have to import the pages and the 3D projection. And right here you have the arrow 3D. Arrow 3D is a class. You will create a arrow 3D. So here we create an arrow 3D from 0, 0, 0, 1, 0, 1. What's that? Your original point, X is 0, destination 1. Y is 0, destination 1. X 0, Y, destination 1. And arrow's shape is like this. Color, black color. Line width 1. Okay? With that, then I do artistic check. So this class actually is just creating the class. Okay? So not important. Your main thing is to draw a 3D arrow. So 3D arrow, that is source destination for the X, source destination for the Y, source destination for the Z, and draw some color and draw it. It will easily draw a draw a vector for you. You'll be from source to destination. Is that okay?
Mm-hmm.
Jessica, is that okay?
Yeah.
So this PyLab, and also MapRoute, we are dealing with these different charts. What I'm showing right here actually maybe is a little bit too difficult, but 2D things will be much easier. Okay, so study the 2D things. Now we have 3D ball. Let's actually try 3D ball. So 3D ball, we are going to plot like this and a arrow that is actually a vector like that. Okay, so we pretty much put back everything together we have so far, the cube, the sphere, and the vector. Okay, we pretty much put them back together, and it will be something like this. Okay, then we know how to draw a point, and next one we are going to draw. Next one we are going to draw the. Actually, let's draw Buckingham Palace. So this is a Buckingham Palace. Actually, draw a lot of point and draw a lot of single point using scatter chart to draw many points, and also draw a few arrow, quite many arrow. And this one we will got this. Let's draw Buckingham Palace. So here actually show you what? Show you. I draw the location for Tyson Lane home and the Buckingham Palace, showing its projection on this angle and this angle and here, right? And I can also show you these two, the angle between them. Is that okay? Is that okay?
Mm-hmm.
And I also show you the 6 axes, S plus, S minus, Y plus, Y minus, and Z plus, B minus. Okay? So that one is like that. And we can also show this one. I also try another one. This one is a simpler chart, but it's just basically no ball. So this one gives us a cleaner idea of what these two are on top of a 3D grid. Is that okay? Okay.
Mm-hmm.
Key point right here is I give you a 3D plotting mechanism. Okay. I know there are a lot of functions you don't know, and it is not possible to learn it in such a short time. So today we pretty much learn GeoPy, right, to calculate the distance. GeoPy, I introduced this only for one purpose. There are thousands of functions that we can use. We are just using a very simple distance function that is just, if there are 300 million steps, I'm just taking the first step. Is that okay? 3D plot very difficult, but I'm trying to give you a 3D plot because last week we already show you a 2D plot already. Is that okay? So today we do this 3D plot. So next one we would have the stone tracker. Okay, stone tracker. I'm going faster on this one to show you how I finish this project. Okay, it will be a 2D study, so it will be easier. Okay. So I have the simple code. Please download from the internet. Okay. Stone tracker number 1. I get this Hurricane Irma data 2017. It actually is August 30 to September 12. Okay. And what happened is that this day, September's day, I originally need to bring Christopher to Florida for a national team trial, but actually this one hit us, so the event got canceled. So I stay home to actually do this. Okay, so this Hurricane Irma actually coming from somewhere in Atlantic Ocean, okay, and then go all the way sweeping through Florida and to inland, okay. So that's the pass we have. So with this pass, we actually want to get a data set. And this data set including date, time, latitude, longitude, pressure, wind speed, and stage. So this is a 6-dimension data. 6-dimension data means what? Means we are using climate model, okay? Climate model actually at a certain longitude, latitude, certain height, certain location. Okay, here don't have the height. I think they may have a standard surface wind speed or something. So at this point, we have certain date and time and pressure and wind speed. We take measure of all the data and put it into Irma text. Is that okay?
Mm-hmm.
So let's take a look on this Irma text, okay? So why am I presenting this? Actually is what? It's actually showing you how to design a project, okay? So first we get data from what? From the National Weather Center, okay? So it's something like this. Okay, so here actually is 30, right? 30 is date. So that would be August 30. August 30, 0000, that actually AM. 0 AM, yeah, okay? And then 30, 6 AM, 12 AM. So every 6 hours, we record some data. And then longitude, latitude, whatever, okay, pressure, they take these different data here. So what we are interested is these two numbers, because these two numbers give us what? 1 point on Earth, right? Hello? Is that okay?
Mm-hmm.
And one thing we need to multiply is what? Hi, Ophelia, why we need to multiply? Hello? Hi, Ophelia, are you okay?
Yeah.
Which data I need to multiply between latitude and longitude? Which one I need to multiply?
7.
7? No, I mean these two numbers, 16.1 and 26.9. Latitude and longitude, which one I need to multiply?
Latitude.
Longitude, because longitude is
Okay.
west. I need to turn them to be negative. Remember that?
Oh.
Remember that when I get it from the Google map, it's that longitude west. West is minus, right? You have a curve that actually is the Greenwich location, and your angle from that actually is negative, right? East to China, that actually is positive. Is that okay? So this number need to averagely be multiplied, okay? Any question? But here actually, we got the pass. We got a pass, so we actually is able to calculate each individual point's location. Okay, we are able to get each individual location. So here actually we have latitude, longitude. Okay, we calculated. We open the file, right? Read the token and then put them split and strip to put them into these different things, and we can print them. After we printing them, we actually put them into a dictionary. So put the date, hour, location, pressure, wind, and type into a dictionary. So after we put into the dictionary, we extract the data to a longitude list and latitude list, and we actually do what? Do calculation, okay? And then we will come out with some data. That would be the X and Y plot we have. And I'm trying to do curve fitting for it. So let's see. So first thing is, here actually I show you the hurricane progress rate. Hurricane progress rate means that every hour, how much longitude change. So what I am curious about is I have a chart. The Irma hurricane do that is I'm recording its difference between every hour, how much it go during different days. And you can see that here is slow down. So most of the time, you actually keep this kind of rate to progress. Is okay? And what happened? Why here is slow down? Amber, why is slow down over there? It hit the Florida, hit the land. Is okay? It hit the land, so it slowed down. If it's still in the ocean, it would be something that is usually hurricane speed drop down when you hit the land and have some obstruction, so it will actually slow down. So now actually we do see the plot. The blue dots are the plot of the longitude over and latitude over plots. Okay, that's the hurricane data. And then we use what? This one is actually quadratic estimation. The blue one is quadratic, okay? And red one is exponential regression, and black one is cubic. So which one is the closer one? I think cubic is closer, right? Cubic is closer. Is that okay?
Mm-hmm.
So we try to have higher order polynomial to do regression. You will get closer to the data set, okay? And you can try different parameter in order to fit the equation in order to get it. And we can calculate the mean square error in order to tune the regression equation to match it. So that's the purpose what we can do study. Once the regression data is almost there, if the data is actually checked for many set of the data and the regression model is correct, so every time the same hurricane come, you actually be able to predict the location by a similar model, then that will become a useful model. Is that okay? So what it is like raw data like this, right? We analyze it and then we do regression. The regression is like this. From the regression, we build an equation model. And just keep tuning. Learn for a long time. And then eventually we got some reliable model. Is that okay? And then use that reliable model, we can do what? We can start to do prediction of the hurricane path. Is that okay? That's the whole purpose that we get started from data set, do regression. Regression is part of the analysis, and then we actually build a model, and eventually we show the model. Okay? Amber, is that okay?
Yeah.
So here, do you need to know everything behind the equation? No, you don't need. In AP Computer Science Principle, the main idea is you need to know what is data creation, what is data analysis, what is the mean square error you try to match, what is data prediction, and what is data model. Okay, AP Computer Science Principle only teaches you this. As for how to do regression, you don't need to know yet, right? You don't need to know yet. We show you here so you can study, but in fact, the exam doesn't need you to do that. Ophelia, right? Hello, Ophelia. Hear me? Hello?
Yeah.
The AP CSP actually do not test on this equation, right? No, right?
No, I don't think so.
This year we only had a project, right? But the written exam is only a multiple choice, right? So the only thing you need to do is actually remember which one to pick, right? Not really ask you to do this Python programming. No, that's too hard. I make it too hard, okay? I make it too hard. I make it too hard on purpose to show you how this data being created and what it is useful, okay? So that's the whole program coming like this. So let's go through the slices. So here we actually get this longitude and latitude, okay? And then we actually from PyLab import everything, and we also need to get from statistics package to get the mean function, okay? And then we open the irma.txt, and then we actually create the title, okay? The title is the first line. So we split the first line and then get the title. Title is what? Title is the first line. These are the titles. These are the title of the data set. So we assign that. Second one, we actually look at the irma.txt, okay? It's like this. Next one, actually, we read in line by line for the irma.txt data model, put into a dictionary, okay? This portion, I think I teach you already. And then each win, we actually use this table to determine the category it is, okay? So we determine that. And then, well, the next portion, we try to actually calculate the path and its progress. This only use a latitude and longitude, but the whole IRMA set, you can do something else. You can monitor its pressure, right? Air pressure. Is that okay? You can use the air pressure and also predict the air pressure over the time. You know what I'm saying? You know what I'm saying? Mm-hmm. The pressure alone is also something you can do it. My interest is only these two columns, but it doesn't mean that the whole data set you can only do research. Okay? My actually is only about that. So I focus on doing that. And I can also get the latitude, longitude, and then what? And then I can post on Google Map if I really want to post it to Google Map. It will show a certain time where is the IRMA hurricane. Is that okay? But I didn't do that. So here actually I read in the data, and then I put that into dictionary, and then I can print the data and hours and location. And then I try to calculate this difference between and difference of the latitude and longitude and the time difference to find out its change of rate. Okay, rate of change. I'm sorry, rate of change. And then we start to use quadratic equation to do checking. And how can I come with this number? These are experience. I look at data and I try a couple of them. These are experience. Okay, I can only say these are experience. And I try my experience number and tune it. Okay, and then process 59 points, and then actually process it with only time, latitude, and longitude. Okay, and then I try to create the chart now. So with three prediction model, we get this. Is that okay?
Mm-hmm.
Okay. So that is Storm Tracker. You can study it. Okay, a lot of code to study. And this kind of project is like, you may not know how it works, but you just study the line by line, trying to understand what this line work, how this line work, okay? And after reading other people's code for a few times, you will pick up the language. Is that okay? Is that okay? That's the whole purpose here. Today, I did not expect you to look at the code first time and you understand it. No. The whole purpose is like, please download it, try to run this, I do some little experiment. Oh, okay, this one works like that. So I can draw a ball, okay, I can draw a vector, something like that, okay? And you keep doing that, you will be able to pick up everything I'm using here. Is that okay? That's the whole purpose. And the best way to do it is just reading the source code and try to analyze it. But I'm not able to teach you every single statement because it takes a super long time to actually just saying that, okay, this we do that, this we do that. Okay, not take too long. It probably take a lot of time and we cannot finish it. Okay, so the best way right now is just showing you, okay, overall this program work like this, and the purpose of doing this is so and so. Please go back and you do study line by line by yourself. And if you have questions, let me know. Is that okay? The next one is this World University. I do not use the code here. Okay, I do not use the code here. So basically right here is to showing you that if I want to see all the university in the world, so I get the data and then I clean the data and visualize it and analyze it. Same thing using the negative and negative. Okay. So here are some data mining techniques and personal data mining. Data mining is trying to actually search through the internet to find the useful data. So here we have geo data. We can make the Google map from user enter data, okay? And use a Google geo data API to run it, okay? We can do such presentation. So basically, with Google data, we use Google load, and then we actually put them into a database. And then we have Google dump.py, and then we show it to a JSON file. We call it where.js, and then where.html will open the where.js file. So what it is actually over here. I can open this one called geodata, okay? So geodata, where here we have a JavaScript file that's written by the geodump program, okay? That's written by geodump program. So there's a where.html. So you write a where.html. So here we have where.html. We can open it by bracket. Okay, it is a HTML file. Okay, it's a HTML file. So we can actually just show it. Yeah, that's a World University location. Is it okay? Is it okay? So the data actually is from this where.js. Okay, it's from this data. Where.js is what? Where.js is a Google geodump data. So what it is that I get the data source from Google data, right? I process it with my Google, GeoLoad, okay? GeoLoad, and then I create a database that's SQL format. And then I use a geodump, dump it to a JSON file format, and then my HTML to do it. So this whole thing I'm showing here is like your Python can cooperate with your HTML. And HTML is your graphic user interface, and Python is a core computation. Is that okay? So that will make a good application. Any question?
Nope.
So all these things we talk about is like we use Python to process the data. Once we have a good data, then we can show to where? show to a web page so people can actually look at it. Is that okay? See my point? So here, every single website, they may have JavaScript to show it, and you will need to prepare data by what? By your Python file. So Python file main idea is getting from data set, cleaning the data, right? Finish cleaning the data, you do regression, matching the data, right? And you build a data model, then store the data to SQL database, and then you can dump to JavaScript JSON data. And then from there, HTML and your JavaScript will pick up, and it will show on your web page. Is that okay?
Mm-hmm.
So that's what the whole modern data science package is. How long you need to learn in order to know about all these? Probably the whole 4 years in college for CS is doing this. Is that okay? So you cannot finish it today with one lecture to learn it, okay? Albert, is that okay?
Yeah.
Yeah? I do not intend to have you to swallow such a big thing in the day. I just give you an idea of, hey, data science is like this. It's fun. You can try to study. You know what I'm saying? That's the whole purpose. I'm not trying to actually ask you to, oh, okay, you need to do everything here. This one is the introductory course. And the next one is the web crawler. Web crawler usually is a very important technique. So for example, like, okay, I'm trying to find the prettiest girl on earth. So let me go through the whole Google search engine and then search for all the girl on any website, taking the picture, and that's analyzed by face recognition, calculated by a certain secret algorithm to rank which girl is the prettiest. That's called web crawler. Is that okay? So it goes through the every web page and then trying to get some data from there, and then you try to analyze it and ranking it or do whatever you want to do. That's called a web crawler. Is that okay?
Mm-hmm.
And trying to find data in the internet in order to do analysis, it's called what? It's called what? It's called data mining. Is that okay? It's called data mining. It's mining the data from the internet. So the data is hidden somewhere in some internet. We need to dig them out. So that's why it's called data mining. Is that okay?
Mm-hmm.
Okay, so here the last two examples, I have the code, but I did not actually go into detail about explaining. So web crawler, you have to have a scheduler, have a queue, trying to continue to check the data from internet. Sometimes web crawling is to get the stock market price. Sometimes it is monitoring the hurricane path. Sometimes it actually is voting. So there are a lot of applications, and what we as a computer science engineer is to do what? Facilitate the computing system so that they are able to actually get the data in, process the data, and provide data for other people, okay? So for example, if I'm actually data scientist and I'm trying to help, say, Donald Trump to win the election, my job is just to get the data from somewhere, provide useful poll result or data present to him. As for how to make decision in campaign strategy, that's not my job. Is that okay?
Mm-hmm.
Is that okay? That's not my job. Okay? Where to campaign money, where actually to hold a big gathering to actually have a boost. I don't know. That's not my job. My job is to analyze which state you are behind or which state you are ahead. Okay? You know what I'm saying? So that's the data science. Okay? And then Google or Amazon have good architecture to help you to facilitate it. Okay? Any question?
Nope.
So today we finished roughly 2-3 applications to show you how a data science project can be done. Okay, maybe the material is a little bit difficult, but don't get frustrated. You can try to read it. I make it a little bit harder because I want you guys to study some technique. Okay, and you can try simpler data set and try to process it. Okay, next week we will be on object-oriented programming, OOP, and then we will start to do graphic design. Is that okay? Using Python. Is that okay?
Mm-hmm.
Okay, so this data analysis about this. And I do not intend to put everything there, but if you actually have some question, I should be able to help you, okay, in terms of process the data, okay? Okay, no question today up to here, okay? I don't have time to practice, maybe some other time to practice the recording back, okay? Good night then, good night, sorry, it's too late, okay? Good night.
Thank you.
Thank you.
Bye.